calculator. Should these be hard? Yeah. All right. So, here's the first one. Ln of 2. Ln of 2.
So is no calculator parts on that?
Nope. There are no calculator parts. Everything is calculator. 0.693. All you did was pop it in your calculator, right? Ln of 2. Okay? Here's the next one. Ln of 0.3. Negative 1.204. Everybody okay so far? Yeah. Anybody need a help? Need questions? All right. What about this one? Ln of negative 1. Why? Okay, so be more, okay, because here, it is not possible. I agree with that. It's not possible. But if I asked you to explain it and you said you can't get a negative 1, I'd be like, well, obviously, duh, because the calculator said you couldn't. Very good. This has a base of what? E. And what is E approximately? 7183. Okay? 2.7183. And it keeps going on, right? Because it's what? It's an irrational number. Alright? But what power could I raise that to and make it a negative number? You can't raise a positive number to any power and get a negative number. Okay? So that's why it's not possible. I just want you to know that. No. It's a real number. Okay.
I know this girl that can do pi. She knows like 13 numbers into it. It's like on a song. They have competition in one of their class, and it's like 3.141596. That's all I know.
Kane, I can't believe you don't know that song. You know every song.
3.1415.
Does Reese know it?
No, Steve and McKinley.
On the radio, like when Coach goes and golf tournaments, he'll try to change the channel just to find something where Reese doesn't know.
So if he can memorize all those songs, he ought to be able to do something in here, right? Use property of logs. Do I need a calculator? No, I don't need a calculator. Here's the first one. Oh, that's sad.
That's for you.
Ln, we didn't record it.
Did we? I don't know.
I don't know. I got really frustrated with the pen and stuff. Maybe I didn't, but I thought I did. Friday, I thought I did. I don't remember getting it. All right, Ln of 1 over E. Y'all look, yeah, if you can't think of what it is, this is what you should be thinking. You should be saying, what's the base of this? How do you know it's the base E? Because it doesn't have an E. Yeah, if it says Ln, that's the only reason it can say Ln is when it has a base of E. So you're saying E, so what power is equal to 1 over E? Well, what power do I raise E to get E? 1, right? And then how do I move it? Because here it's on the top and here it's on the bottom. How do I move it from the top to the bottom? So there's my answer, -1. Okay? Here's the next one. Are you ready? These are properties. Properties. E raised to the Ln of 5. Yeah.
But can you just put that in your calculator?
You can put that in your calculator. But now look, what could someone do? Because are there parts of tests that they are now saying you can't use the calculator on? Y'all, they are. They're doing that. I know that a lot of y'all.
On your test.
Yeah, on my test you got a calculator, but I mean the whole point of me teaching you is not just my test, right?
Yeah.
It's for you to be successful in whatever you choose to do
that
next.
one works. I didn't know if all of them don't work. So.
They will. How does what work? This one, okay, if this base and this base right here are the same, there's the answer.
Yeah, I get that, but it's just how you get it. Because it's an exponent, so it's just really weird.
Let me see if I can figure out. They just kind of cancel each other out.
It works on the file.
Yeah. I know it works that way. So let's see.
Just do ln to the fifth. What's that?
Okay, let's rewrite that as a...
So e
this
up
would be
to that number.
e to the...
E to the what?
Oh. This would be e raised to what power is equal to 5?
1.6094.
E to the what power is equal to 5? That's what that is. I don't know.
But,
I don't know how to explain
yeah,
it to you. It's just a property thing. Yeah, and it's the one, to me, that's the hardest one. I mean, and like I told, this is what I told y'all to remember, okay? There's the answer, okay? There's another one that's like this that looks like this. I'm going to do it with a log, so I think you'll see it the best. Log base 2 of 2 to the 6 is equal to what? Yeah. Okay? A logarithm is an exponent. There's your exponent. That's what it's equal to. But this one's easier to explain because I can say 2 to what power is equal to 2 to the 6. Well, it's 6. Okay? But that one, I don't really know how to rewrite it to show y'all that. I'll ask Mr. Ryan, and he probably can do it. I may not get it.
Well, did you see the same thing as like
Do it. That's what I was kind of trying to do.
E up to
e
that
to the
number.
what power equals e to the fifth?
But that's not e to the 5th. That's a base e. See what I'm saying?
Yeah.
So it's kind of hard to write it. I don't know. I'll ask Mr. Ryan and see if he can show me. Okay, let's do this one. This one looks like this. ln of e to the 0.
0.
Yeah, it is 0. Okay? And I'm going to tell you that on this one, you could work this one out. You don't even, on this one, because of what it is, you could use your knowledge of it and work it out. Because you could say, well, that's ln of, what is e to the 0 power? 1. And then e to what power is equal to 1? 0. Or you could just look at here and say, hey, this base and this base are the same. There's my exponent, and a logarithm is an exponent.
But there was
Okay.
a negative up there. Would that work?
A negative right there?
Yeah.
Because your exponent can be negative.
Yeah. I mean,
Just
your
your
answer
answer.
would be, what would your answer be?
Negative. Like if you're, like
And
if
it'd be
you
that
had
same number, though.
ln, of e to the negative 2 is
Negative 2.
negative
Okay.
2. Okay? Alright, let me see if there's, oh, there's one more. This one looks like this. 2 ln of e. 2 ln of e. This one's kind of a process one. It's using properties, but you have to do something. ln of e is what? 1. So what's 2 times 1? So that's what your answer is. Okay?
Is it always that number up front?
Because ln of e is 1. E to the what power is e? 1. Alright. Let's do another one. This the next one. This is example 9. We'll see how good these go. These say find the domain. So what will some people start to do right now? Yeah. PreCal, start to sweat, whatever. Okay? Yeah, you can, but we're not going to. Okay? On the if it was a test, then I'd do it in my head and then I'd check it on my calculator, right? Okay, but I wanna see if we can do them without a calculator. Okay? So first of all, they're all natural logs. Okay? What does the graph of a natural log look like? Does it have an asymptote? Where? X equals 0. Y'all, it's not y equals 0 because that's an exponential. Okay? It's x equals 0. And then it goes through this point right here, which is 1, 0. Now, y'all look. It doesn't matter if it's a natural. It doesn't matter really what the base is. It's going to look like that. Does everybody understand? It could be log base 2 of x. It could be log base 10, log base whatever. This is just ln, which is log base e. That's all it is. Okay? So it's still going to look like that. Now, what's going to happen to that if you do this? Because this is the first one. F of x is equal to ln of x minus 2. What does that do to that graph? Well, first of all, let's go over here on this graph. What's the domain of this graph? 0 to positive infinity. 0 is excluded, right, because it is my asymptote. What is the range of this function? Yeah, he's negative infinity to positive infinity. He goes all the way down and all the way up. All right, so over here, what does that minus 2 do to this graph? It moves it right 2. So now what's my vertical asymptote? X equals 2, okay? And it's just going to shift that curve over. He's going to be right here, okay? And then he's going to go like that.
He goes all the way through, right?
Huh?
It goes all the way down?
Yes. Now look, here's the big thing. Here's the big thing. When you look at it on a calculator, when you look at it on a calculator, it doesn't look like it goes all the way down, does it? But it's that asymptote thing where it gets so close to it that it actually goes over on top of it. Okay? So tell me what his domain is. 2 exclusive to positive infinity. Okay? Let's do another one. This one's going to be tricky. Alright? I'm going to let you do it. G of x is equal to ln of 2 minus x. The first thing I would do is I would rewrite that in a form that I was more familiar with. Okay? I'd just make that stuff look a little nicer. I'm going to use this graph, but I'm going to erase all that stuff while y'all do it. Yep. Now look, did I say pop it in your calculator and tell me what it looks like? No, I didn't, people. I said try to do it without a calculator. That shows more knowledge. Okay? And that makes you think besides just depending on some stupid machine. Alright, y'all got it? Everybody okay? Okay, so the first thing I would have done, and I would have rewritten it as what? Negative x plus 2. Okay? Now, what is that negative on that x going to do? Reflects it over the y-axis. When? Yeah, last thing you do, guys. Remember how we say x's are weird and they're always weird? When that negative is on the y, that's the first thing you do. Okay? And then if it's on the x, it's the last thing that you do. So what's this plus 2 going to do to this? Let's do the asymptote. Move it to the left 2. So now this is going to be my asymptote. Does everybody agree? And then my little graph is going to look something like this. Everybody with me? Now, you have to take this right here. Oh, I should do this right here and flip it over here, because I can't do this and flip my hand all the way around. Okay? So this and flip it over here. So now, really, the asymptote is where? At 2. Yeah, I do. Okay? So this is my asymptote. Okay? And which way does this little thing go? He goes the other way. Okay? So he's going to look like that. So what's his domain? Perfect. Negative infinity to 2. Inclusive or exclusive? Very good. All right, let's do one more. Let's do this one. Weirdo one. A sub x is equal to ln of x squared. Now, let's look at this white guy, because he's my parent function, okay? He's just this one, ln of x, right? Now, what do you know about x? What can x be? Any number in the whole wide world? Not a negative number. Can it be a 0? No, that's not asymptote. You can't raise a number to a power and get 0 unless that number is 0, right? So it has to have a 0 base, and that's not allowed. All right, so these are only numbers that are to the right of the y-axis. Does everybody agree? Because they have to be positive. So now I squared it. When you squared something, what is it always? Positive. Does it matter if it's negative or positive? If I square it, it's going to be positive. So now, look what I've done. Yeah, you got this part right over here, but you got something over there on the other side, too. So watch what's going to happen. It's going to make sense. This is what it's going to look like. Okay, now here's my question. Does that thing come down here and then bounce back up like that?
No, it goes all the way down.
Why? How do you know it's not 0? It can't be 0, right? What, ln of 0. What is ln of 0? What power do you raise e to and get 0? Nothing. It doesn't work. And if you wanted to check, you could go second and table and look at it, and it would tell you that 0 is an asymptote. 0 says error, so that's not asymptote. So even though it appears to be like a bird thing, it's really not. It's going down here, and it keeps going, and it keeps going on either side. Okay, and at x equals 0. So what is my domain for this function? Negative infinity to 0, exclusive. Very good. 0 to positive infinity. All right, good deal. Everybody okay? Okay. So the last thing we're going to do is we're going to work example 10. It's called the human memory model. Human memory. Oh. What was that? Where did it hit? I know.
One of the doors open here and closing. Somewhere. I think it might have been the outside door.
Yeah, could have been, because then it affected everything. Alright, so human memory model. Here's what's happening. Students participating in a psychology experiment attended several lectures on a subject, and then they were given an exam. Alright, so we got kids going to a lecture, and then they're going to give them an exam. Every month for a year after the exam, the students were retested to see how much of the material that they remembered. The average scores. Now, this is what everybody scores. No, this is just the average scores. The average scores for the group are given by the human memory model. And here it is. F of t, because it is a function of time. Okay? The longer it goes, the less you're likely to remember. So 75 minus 6 times the ln of t plus 1. T is my time. We're doing it for a year, all right? So t is going to be greater than or equal to 0, less than or equal to 12. That's the restriction that they gave me. So what do I know that t has to be in months? Okay, because they said we did it for a whole year. All right, so let's see. The very first thing I want to know is what was my original score? Now, if it's an original score, what's t going to be? Very good. That's right after the lecture. We're going to go in there. We're going to take a test. We're going to see who all that's going to give us our baseline. All right. So we're going to plug a 0 in. 75 minus 6 times the ln of 0 plus 1. What's my score? Y'all do it on your calculator. 75? Okay, so on average, we scored a 75 on our exam. Okay? All right, here's the next one. That was what? Okay, this side over here. I want to know what it is in 2 months. This side over here. I want to know what it is in 6 months. You think there's going to be a huge difference between 2 months and 6 months? Think about 6 months ago, guys. That was Christmas. Well, it was getting close to Christmas. Actually, it was Thanksgiving, wasn't it? Yeah. I hope y'all remember some of that because we're going to have to take a day and go over that test and stuff, and then I'll have to give y'all that test. And you got to, if you want to take the Cone-Hole test. I haven't decided what I don't. They're not going to make me do something, but they want us to take a day. They want us to take a day out of class. That's probably what we'll do. Why? That's not right. That's not right. No, that's real. I thought you said you were.
You're not right?
Abby. No, what is it?
Wow.
Okay, so 2 months. What'd y'all get? Point, round off 1 decimal place. 0.4. 68.4. What is it at 6 months? 63. 23. Okay? So,
Oh, wait a second. I just put 75.
oh. That'll make a difference.
I put 25 the first time and it said 13. I was like, dang, they really...
They forgot a lot. Bless their heart. All right. So, anybody got a question? Okay, so here's what we have going on. I'm going to pass out your worksheets, and I have to apologize that, yeah, I'll stop in a second. So if anybody's not here, they'll know what's going on. I don't know what happened, but anyway, there's a page that's missing. The kids were asking me about number 16 or something, and I was like, where is 16? And they were like, it's on the back of the front page. And I'm like, no, it's not. Oh, my gosh, I'm missing the whole page. And then I realized that this didn't. So I'm going to go ahead and give them to you because otherwise you wouldn't be able to start. And then we'll just pop that page on the back of it, okay? So there is a page missing. So you guys will have the rest. You will have Tuesday, Wednesday, and Thursday to work on this. We don't have 45-minute classes, though, okay? We only have 35-minute classes. I think that's what they are. So, and let me warn you about this, too. If you're thinking, I'm just going to skip 5th period, what are they going to do if you miss 5th period? They're going to count you absent for the whole stinking day, people. Okay? That's the way they're playing the game. So, know that and don't be absent, all right? okay? Don't be absent. But this is what we're working on. It's going to be due on Friday when you will have a test, Friday, Monday. I've already sent out a remind, okay, that your worksheets and your tests are Friday, and then I sent you another remind on Sunday that don't forget your test, your second part of the test is tomorrow.
Yeah, how's the schedule working this week? Because